This is the main menu. The main menu is parted in 4 selections: the general part, the inspection part, the imager part, and the part of the inspection surfaces. This part is product qualified and looks different at other surfaces. In the general part, there are 4 submenus. To execute and edify the users, you choose User Administration. This is only possible as a registered administrator. You can generate a new user if you click onto the button New User. Therefore, numbers and letters are permitted. The user hierarchy includes 3 different user types. Supervisors have mostly the same rights as the administrator. Administrators are the only ones which can access the user administration and provide master jobs. More of this at the submenu Jobs. The function AutoLogout provides the safety. After a magic state of the logged-in administrator, this function kicks the admin out of a non-serve level. It is suggested that you register every user type to arrange a solid hierarchy. At the application protocol, all actions are listed which were carried out under this menu. You can delete a user under Delete Entry. If users were provided, you can log anyone in. You can change the language of the system at the system settings. There's also the possibility to adjust the clock time and regulate different time zones. You can notify the system identity of the current programs also from the external machines. At the system management, you can clean up the system by deleting any data like pictures, charts, and jobs. At network settings, the settings of the remote of a system are defined. To get an additional selection of functions, you go to the point Service Functions. Under the program Update, the software can be updated to a desired version. You can get these versions over the internet or by request of Ibea as a USB stick. To load the version from a USB stick, you click on New Search and afterwards on Loading. To get the system onto the new version, you need to press the key combination Ctrl-Option-Backspace. During the following appearing register mask, you register a service user with the password service. Now you open the shell and type in the following command. The installation begins. When the installation is done, you need to press again the key combination. Now you can work with the new installed version. Under CRTS functioning test, there is the possibility to review the trigger and pusher functions plus tensions. With switched on product line, the trigger should blink and the gear clock should count up. If one of the functions isn't working, it could be because of a damaged trigger gate or rather a damaged pusher. This value should have at least 40 volts. Approximate value is here 48 to 49 volts. More functions can be tested. The favored exits can be checked with a click on the adjoining box. More external signals can be checked at the availability. The CRTS configuration is intended for the setting of the zoom or rather the lift. Here, the engine levels can be defined. These settings should be only changed by a server. This window appears to check the validity of the current software license. To use the software onboard, the certification code must be typed in, which will be delivered by Ibea. Additional components like keyboard, display, and others can be tested. There is the possibility to transfer the created screenshots directly to your USB stick. To generate screenshots, you should use the internal Linux program. This is useful for eventual problems with the software to get help by colleagues or service staff. The pictures are transferred as BMP. You have the possibility to create new groups and jobs under the menu point Job. To generate a new group, you choose an optional group name. Then type in the name in the area and press Enter. It's the same procedure for the jobs. The established groups and the corresponding jobs are now shown at the job archive. Every already called jobs will be automatically saved and reclassified. Also, there is an additional option, saving jobs as. Now there is generated a copy with a different name. The same result will be achieved with the option Copy the job, or rather the key combination F3. To bring the jobs onto a preset, you choose the option Backup job. There is the possibility to draw a summary list, for example, of the USB stick to see the already listed jobs. An administrator can load an already chosen job as a master job so that it is for no one else available. To re-establish a job, you mark the former steps, mark a point of time, and click to Loading Job. The job is now recessed to the selected date. The push button External Medium offers the possibility to choose a data medium, like for example a USB stick, to transfer the data or rather export the groups and jobs. At the menu item Work Image, there is a different recorder mode. You can choose Live to have a look at the current camera picture. To record a series of pictures, choose an optional number and place the mark at Run. At running production, they are now automatically taking pictures. The option gives the opportunity at non-presence and stop production to catch recorded pictures and save them. The window Photo Archive allows to request the pictures at any time. Non-desired photos can be easily removed and deleted. The point Save Picture is important to save and manage the pictures and to export them to the data medium. At the export to an USB stick, you can automatically save the pictures as BMP. To delete the image archive, you choose Delete In and Image Archive. To fill in the image archive again, you choose Loading Off. You can always put optional comments to those pictures, but the data names can't be renamed. To fade in reference lines, you need to place a check mark. To configure it, you need to click on the button Preference line. Choose between vertical and horizontal lines to choose the desired function. This offers the possibility to measure pieces. There's also the option to choose different color matchings. For that, you go to the display mode, choose false colors and register the desired values. There's also the under menu for the lighting settings. We distinguish first of all three elements: beam, dome, and corona. These elements have each three light groups: red, green, and blue. The dome is also separated in inside, middle, and outside. The pulse width can be adjusted from an 1/8000th to a 1/500 seconds. This setting should be made in dependence to conveying velocity. The pulse width needs to be decreased when there's a problem with the blurring. This should be balanced with the iris. Because of the amendment of the lightning groups, defects like this blinky can be made visible. At the histogram, this defect is shown as an irradiation. When you turn off the beam, the lightning won't be reflected, and this defect isn't visible and can't be distinct from the dirt. During a test run, the already taken lightning settings can be tested. This is the submenu Positions. Here, the positions of the camera and the photosensor can be adjusted and balanced. The trigger can be used as leading or falling. Leading is if the object reaches the photosensor. Falling is if the object leaves the photosensor. The photosensor should be placed as tight as possible to the camera middle for avoiding grids. The distance will be indicated in gear clocks. Those gear clocks will be counted from an encoder at the flat conveyor. With a delay between light barrier and camera middle, the photos will be taken. Those photos can be saved automatically. The pushers lie in this order in a row at the flat conveyor. Here, the delay is defined in gear clock steps from image acquisition to throw-off. This value needs to be balloted with the conveying velocity. If there is a timeout, the distance of the pusher to the camera middle needs to be increased mechanically. A timeout arises when the system hasn't enough time for the evaluation. The duration determines the time between the opening and the closing of the pusher valve. The MAC compressed air valves need approximate 40 to 60 milliseconds until expulsion. Settings under 10 milliseconds are too short and cause the problem that they won't come out. In addition to the 3 pusher settings, there can be arranged a control which will review if the dropped out objects are actually dropped out. At the teach-in, the pusher will be activated or deactivated. During a test mode, the pusher functions can be tested. The object lengths can be adjusted. This is used to avoid double trigger. The object lengths can be located with a sensor measuring. We are now at the submenu Object Separation. It provides the separation of the objects in case there are more than one object in one photo. The active area can be minimized to decrease the time required for computing. The black areas outside the active area won't be calculated. The active area can be maximized with one click. If the camera picture shows a bright background, you should place a check mark at bright background. At threshold value, you enter a contrast at which the object isolation rectangle should enlace the object. Ideally, you choose a mean value of the requirement area. Object pieces like the curl step out of the threshold value. To scrutinize those areas, anyway, there's a reserve width. It enables to balance small variabilities at the object compartmentation. At the point separation, you can adjust to which areas neighbor objects are allowed. You can choose between horizontal and vertical running direction. This approach is very useful for high-speed lines. The red circle surrenders through the predetermined middle in which is placed a search circle. The green circle corresponds to the green rectangle, which was adjusted at the object separation. At amendment of the threshold value, the final tight enlacement of the object will be adjusted. The threshold value should be adjusted with attention so that there is a centered enlacement of the outer outline. The search area is a limit of the area in which the object middle should be charged. You can adjust the tolerance of the pieces which jut out of the edge with a breakout border. Everything what is more than the yellow line won't be calculated at the centering. Those values are generally adjusted to 0. At the symmetry evaluation, the object will be partitioned in quarters across the lux numbers in individual pieces. The contours of the individual quarters will be compared and represented at the histogram. The symmetry evaluation must be activated to use it later on at the teach-in. Under reference figure, the calculated rated value is shown in pixel. At the field next to it, you register the reference size of the object. This should be adjusted only one time and shouldn't be modified. At the submenu Lux, there can be activated a Lux finding. You choose a search area in which the Lux are located. The constraints of the search area are shown as blue circles. You can choose between 3 different methods. Here, the Lux will be searched over the outer outlines, brightness and contrast. The procedure should be selected in connection to the object characteristic. For objects with different colorful curl or lux, the procedure isn't suitable. If necessary, the lighting must be adjusted again. Alternatively, you need to relinquish to the clean adaptive lux finding and adjust the lux symmetric, parametric, or geometric. Parametric is a combination of simulated adjusted and measured adjusted values. For geometric, you have to rely to result of centering of the lux. At the field curl, the inner area of the curl will be defined. In those fields, the complete shape can be identified. This setting is dependent of the previous settings of the lux size. Under Logtop, you can adjust an angular displacement to localize the lug area. The object is now geometrically captured through the curls, object middle, lux outlines, and lux middle. Under the reflecting surface, you determine the single surfaces which should be evaluated. Those surfaces are also named region of interest, ROI. The surfaces can be adjusted through 2 radiuses. The bigger the surface, the more pixels will be evaluated. The histogram must be noticed as an auxiliary tool. The histogram, the pixel data of the object picture, are shown as gray tones in a brightness sector from 0 to 100. A black pixel is shown left at the histogram. A white pixel on the left side. Every gray tone is shown here. Is only the mirror area selected, the dirt can be differentiated from the defects like blinkies. During production, the lacquer can have more color shades, so there are 3 different procedures which will consider that. Those procedures are called radial, circular, and linear. The circulation procedure contains product-independent data for cans and also for ground testing. The procedure compares pieces of the picture with help of a spiral stairs algorithm from the inside to the outside. For circular, there are 3 setting options. Gain means strengthening of the differences of the neighbor pixel. Difference to the brightness are shown with light blue, light red, and white. Differences to the dark are shown with dark green, dark blue, and black. As usual, gain value is 2. At symmetry, the number of partitions can be identified. The value 0 means an observation of the whole surface. 1 means 2 halves, 2 means a double partition, and so on. Those pie slices will be compared with each other and the system calculated a value. The more often the partition, the more accurate is the gray value. However, it will be used more storage and more time. There is the possibility to adjust a noise suppression. Here, the additional picture noise will be filtered and the mistake is clearly visible at the histogram. The radial procedure works like the circular procedure with one difference. It examines the picture radiant from the inside to the outside. The difference is that radial would recognize the transition as a mistake. A circular scan determines the transition. The symmetry parameter will be replaced by the order parameter. The local evaluation compares the differences of one pixel with its neighbor pixel over the whole surface. To get the best results for the evaluation, the object must be separated in several surfaces. The transition will be checked separately through another circular scan. The sensitivity can be pulled down in this area. The compound area, also called dip, can be verified circular and radial. For asserting underlaps, you should choose radial. The area can be checked additionally to find gray tones and to recognize possible underlaps. The mirror should be checked additionally. This warranted a correct examination of the lacquer. If that is not available because of a manufacturing error, the circular and also the radial method wouldn't recognize it as a mistake. At the menu ROI names, the defined levels can be renamed. At the teach-in, the threshold values will be defined. The constraints will be adjusted so that the products without any damage can pass and the faulty ones can be identified. At the regular mode are parameters like min, max, low and high. Min represents the higher and max the lower threshold value. The parameter high and low form the tolerance values in the pixel to the left of the lower threshold and to the right of the higher threshold. High would be the amount of the brighter pixel outside the definite thresholds. If the amount of pixel overruns the threshold value, the area will be displaced red and the product will be classified as faulty. For the section Paint, the mode Min should be chosen. For that, it is not interesting if the error is present, but if the brightness of the paint changed. Min is the method for the average determination. If there are burns at the paint, the histogram at the left or right would manifest conspicuous values and there would be a flawless evaluation. The dip should be tested with a tight tolerant value, for example 10. If there is a contraction, there would be a faultier pixel than 10. The underlap would be analyzed correctly. At the mode dynamic, the histogram will be weighted from the middle. Left for dark errors, right for bright errors. If there was activated a balance evaluation before, the lux profile and the outer shape can be compared at the teach-in. The outer shape will be checked through a separation of the lux. Therefore, it will be compared if the single areas have similar outer shape. Also, the caliber of the cap can be checked. Under PU, you can switch the pusher. At this point, it is possible to choose which pusher is responsible for which error area. The lug area can be checked circular or radial. With the circular method, it is possible to adjust the strengthening with a gain. The missing compound area between the lugs can be defined here. These areas can be separated with two further parameters. This is a helpful solution to rate the curl and the lugs from each other. The thresholds and the tolerances must be adjusted at the teach-in. At the indicator browser, all photos from the start can be tested with the current settings. This works also at running production. Every brown beam represents a photo. With one click to a beam, the corresponding photo will be shown. The upper green and the lower red stroke place the thresholds at the teach-in. Some beams jut out of the threshold, means they were placed wrongly. At the paint area, there aren't any mistaken photos. Here, the threshold values can be highly narrowed. At the transition, it should be extended a bit. This cap has scratch marks at the curls and is flawed at the indicator browser. Because this product is flawless, the upper threshold should be widening out. The missing compound area, the curls and the aperture are accurate at all photos. At the indicator browser, the quality of the settings can be tested well. If the inspection is ready for takeoff and there aren't any faulty affiliations, it will be shown here. At the display, you can choose what you want to see. Every object or only the faulty objects. Autosaving saves all inspected objects into the working storage. The inspection can be activated with one click. Stop deactivates the inspection. Here, the amount of all examined objects are shown and which one of them were flawless and which one of them were faulty. Timeouts are also shown here. If there aren't any timeouts, the pusher was positioned correctly. But if the distance to the pusher is too low, all objects would be ejected through a timeout. The theatrical window is dependent of the calculating time. At 90 milliseconds, 10 objects in 1 second can be evaluated. If a photo has a mistake at the curls, which wasn't found so far, it is possible to change the threshold and the settings for the running inspection over the teach-in. There is the possibility to set an alarm. If the amount of faulty objects overshoots the tolerance, the alarm will go on. At this point, the pusher function can be prevented completely. The pencil simulated a collection sequence of faulty objects. Those faults will be captured directly and the objects will be thrown out. Faulty objects have a colorful insertion. At Pareto analysis, all identified mistakes are listed. There is also the possibility to arrange a high reject indicator beam. At the teach-in, you can choose which scans should be affected. At the indicated browser, all photos will be calculated and listed. At the statistic journal, all records can be listed. If an inspection was stopped and started again, there will be a new record. Those records can be exported as CSV data.